In this training, we are going to talk about the basics of Autodesk Civil 3D. We are going to discuss the following topics. 1. Civil 3D interface. 2. Import points, export points, and manual point creation. 3. Surface creation. 4. Polyline creation. And 5. Road design creation. Let's begin the discussion with Civil 3D interface. Application menu. In the application menu, you can find several options such as Create New Workspace, Open an existing drawing, Save drawing, Export drawing to different formats, and change drawing settings. In the Drawing Settings window, you can change several drawing settings such as Drawing Unit of Measurement, Angular Unit, Scale, Projection, and Coordinate System. Quick Access Toolbar. In the Quick Access Toolbar, you can find some of the options very quickly. You can also select and add other options on the Quick Access Toolbar. Ribbon. In Ribbon, you can select several tabs such as Home, Insert, Annotate, Modify, Analyze, View, Manage, and more. Panel. Under each tab, you can find different panels. For example, in Home tab, you can find palettes, Explore, Create Ground Data, Create Design, Profile and Sections View, Draw, Modify, Layers, and Clipboards. File tab. In File tab, you can find the open drawings, Visual Controls. In Visual Controls, you change the visual style of the drawing such as 2D wireframe, Conceptual, Hidden, Realistic, Shaded, and more. Tool Space. Tool Space contains options to create drawing elements such as points, point group, surfaces, alignments, and more. Transparent command bar. Transparent command bar contains command such as angle distance, bearing distance, azimuth distance, and more. View cube. The view cube can be used to rotate the drawing objects to different views such as top, front, bottom, back, left and right side. Coordinate system. Coordinate system button can be used to change coordinate system orientation relative to main compass directions. For example, this is standard world coordinate system. North to south is equivalent to Y, and east to west is equivalent to X. Using this button you can change the relationship between the coordinate system to the standard compass direction as shown. Navigation bar. The navigation bar is used to pan, orbit, and zoom extents to display maximum extent of all objects in the drawing. Command bar. In the command bar, you can type the command you want to execute. For example, to create a polyline, type command PL, then enter. Status bar. Status bar is used to turn on or off functions such as cursor snap function. Turning snap function on will enable you to accurately select points on an existing drawing objects. For example, if you want to draw a line from the center of this circle to the midpoint of this line, you have to turn on midpoint and center on the object snap setting to accurately draw the line. If the midpoint and center is off in the object snap setting, it will be difficult to select the midpoint of the line and center of the circle. Model and Layout tab. Model and Layout tab is used to transfer from model to layout view and vice versa. Coordinates. Coordinate System button is used to view coordinate system orientation. Workspace. Lastly, workspace is where you create the drawing elements. Now, let's discuss about how to import point data to Autodesk Civil 3D. To import points to Civil 3D, click on the Home tab. In the Create Ground Data panel, left-click on Points. Then, select Points Creation Tools. On the Create Points window, left-click on the Import Points button. On the Import Points window, left-click on Add Files button to select and add point file. Then, specify the point format of the file. You can group the points by checking the Add Points to Points group box. Click Create Group button to add the points to an existing point group or name a new point group. Then, left-click OK to import the points. Now, points has been imported. This is how we export points from Autodesk Civil 3D. To export points from Civil 3D, select the points to be exported from the workspace. In the Kobo Point Tools tab, click Export. In the Export Point window, set File Format. Then, select File Destination. Type file name. Set file type. And click Open. Now, click OK to export the points. Let's create point manually. To manually add a point, select Home tab. Left-click on Points. Hover the mouse cursor on Create Points, Miscellaneous. Then left-click Manual, while Create Point window is open. Specify the point location by left-clicking on the workspace. Type the point description. Then press Enter key on your keyboard. Type elevation value of the point. Then press Enter key on your keyboard. Now, the point has been created. Now, let's add labels to the point we created. To add or modify point labels, select the point/points from the workspace. Then, right-click anywhere on the workspace and select Properties. On the Properties window, under Information, left-click on Point Label Style. Then select and set the desired label style. 1 is the point number, 500 is the point elevation, and A is the point description. Let's create tin surface. Now let's create a surface using the points we imported earlier. To create surface, select Home tab. On the Create Ground Data panel, left-click Surface. Then, left-click Create Surface. On Create Surface window, edit Name. Type e.g. Surface. Style, use Default. And Render Material, use Default. Then click OK. Next, on the toolspace, left-click Prospector tab. Then, left-click Surface drop-down button. Left-click e.g. Surface drop-down button. Then, under Definition, left-click Point Group. And select Add. On the Point Group window, select Point Group where you want to create the surface. This time let's select Existing Ground by left-clicking the point group name. Finally, left-click Apply. And then OK. Now, surface has been created. Let's draw a polyline. To create a polyline, start by typing Command PL in the command bar and then Enter. Then, draw the polyline on the workspace. Now let's draw a polyline traversing the existing ground surface. Specify starting point by left-clicking on the selected location. Then, specify and select the next points using the same action. To end polyline creation, right-click on the workspace, then click Enter, or you can press Escape key on your keyboard. Now let's design a road. Let's start with road alignment. On the Create Design panel, select Alignment. Then, click Create Alignment from Object. Then, select the polyline on the workspace. Then, press Enter twice in your keyboard. On the Create Alignment from Objects window, set the following parameters. Name is Road 1. Type is Centerline. Alignment style is Proposed. Alignment label set is All Labels. Then, click OK. Now, road alignment has been created. Next to alignment is road assembly. Now let's create road assembly. On the Create Design panel, left-click Assembly. Then, select Create Assembly. On Create Assembly window, type name. This time type 3RROW. Then, click OK. Now, specify location of assembly on the workspace. Road assembly has been created. Now, let's create road sub-assemblies. To create road subassembly, select Road Assembly on the workspace. On Launchpad panel, left-click the tool palettes. On the Tool Palettes window, select Lane tab. Then, left-click Generic Pavement Structure. Now, left-click on the left side and right side of the road assembly to install road sub-assemblies to road assembly. Finally, press Escape key on your keyboard to end road subassembly creation. Now, let's edit lane properties. On the workspace, left-click on the right lane. Then, right-click anywhere in the workspace. And then, select Properties. On the Properties window, under Parameters, set the width to 3 meters. Now, do the same on the left lane. After the lanes, let's now add the road curb and gutters. On the Tool Palettes, select Basic tab. And then, select Basic Curb and Gutter. Attach the curb and gutter to the left side and right side lanes by left-clicking as shown. Then, press Escape key on your keyboard. Next, let's add daylight. On the Tool Palettes, select Daylight tab. And then, select Daylight General. Attach daylight to the left side and right side curb and gutter by left-clicking as shown. Then, press Escape key on your keyboard. Now, all sub-assemblies have been created. Let's create existing ground profile. In Home ribbon, under Create Design panel, left-click Profile. And then, select Create Surface Profile. On Create Profile from Surface window, select the alignment of the profile you want to create. In this case we only have one alignment, which is Road 1. Then select Surface. This time select EG Surface. Now click Add. And then, left-click Draw in Profile View. On Create Profile View window, change Profile View name to Existing Ground. Then, left-click Create Profile View. Now, select the location on the workspace. Then, left-click to draw the profile. The red line is the existing ground profile along the center of the road. It shows the ground elevation in every stations of the road. Now, let's create the road final elevation. To create road design profile, select Home tab. On the Create Design panel, left-click Profile. And then, select Profile Creation Tools. Then, left-click on the existing road profile in the workspace. On the Create Profile Draw New window, set profile name. This time let's type Design Profile. Then, left-click OK. On the Profile Layout tools, select Draw Tangents with Curves. And then, draw the road design profile as shown. Left-click to draw the line. Press Escape key on your keyboard to end design profile creation. The blue line shows the road design profile. To update the profile view band and show the design elevation, select the road profile in the workspace. Next, left-click Modify View Panel. And then, select Profile View Properties. On the Profile View Properties window, left-click Bands tab. Then, set Profile 2 as Design Profile. Then, click Apply. And click OK. Now, road design elevation is shown on the profile view band. In station 0+000, existing ground elevation is 110.30 meters, and the design elevation is 106.0 meters. Finally, we can now create road corridor. A corridor is the 3D representation of a road within the Civil 3D model. On the Home tab, under Create Design panel, left-click Corridor. And then, select Corridor. On Create Corridor window, set corridor name as Road 1. Set baseline type as Alignment and Profile. Then, select Alignment. This time we only have one alignment, which is Road 1. And then, set Profile as Design Profile. Next, select Assembly. Right now we only have one assembly, which is 3RROW. Then, select Target Surface. This time I only have one surface, which is EG Surface. Next, check Baseline and Region Parameters box. And then, click OK. On the Baseline and Region Parameters window, click Apply. Select Rebuild the Corridor. And then, click OK. The corridor is now created. Now, let's create road cross-section view. To create cross-section view, we need to create sample lines first. To do that, select Corridor in your workspace. Then, right-click anywhere in the workspace and choose Corridor Properties. On Corridor Properties window, select Surface tab. Left-click Create a Corridor Surface button. Then, set Overhang Correction to Top Links. Then, change Specify Code to Datum. And then, click Green Plus button. On Corridor Properties window, select Boundaries tab. Right-click on Corridor Name. Then, select Add Automatically. Select Daylight. And click OK. Then, select Rebuild the corridor. Now, on Profile and Section Views panel, left-click on Sample Line. Then, left-click on the alignment in the workspace. On the Create Sample Line group, set Style to Finish Ground. Then, click OK. On the Sample Line Tools window, select Sample Line Creation Method. Then, set to by range of stations. Next, you can change the increments of sample lines, but in this case let's use the default 20-meter increment. And then, click OK. Close Sample Line Tools window. Now, sample lines are created. Finally, we can now create road cross-section view. On the Profile and Section Views panel, left-click Section Views. And then, select Create Multiple Views. On the Create Multiple Section Views window, select Alignment. And select Sample Line Group. Click on Create Section Views. Then, click on the workspace to draw the cross-section views. We now have road cross-section drawing in every 20 meters increment of the road alignment.